Hello everyone. So today we are going to solve a LeetCode problem, problem number 16, which is three sum closest. Okay. So we have already solved, like all of us know that there is a very popular and common questions is two sum problems and three sum problems, and this is the advanced version of three sum problem. Okay, this is a just extended version. And recently in Google L4 position, for Google L4 position, this question was asked. That's why I am solving it. Like previously I have solved longest valid parenthesis, which was the extension of valid parenthesis, and now I am going to solve three sum closest, uh, which is a extended version of three sum problem. Okay, now if we go for the problem, so we all know that we can easily okay, let's understand the problem first. As the normal of three sum, if you have done that three sum problem, you will know that, yeah, that the three number of this array, the given array, we have to take three numbers and we have to see the target, if we can achieve the target or not. Okay, so but in that was in three sum problem, and we have to return the values or indexes, maybe in different case problem, different in maybe indexes, or maybe the yes booleanly yes or true, that we can find it. That's why that's how it was happening. Now in this case we have to return the closest. Okay, so in the array you will not find, you may not find the target is, you may not achieve the target. Okay, so that in that case you have to return the closest target, closest which is closest to the target, the number which is closest to the target, you have to return that. So now see, if we go for this example, then we can see that if we take first three numbers, then the sum will be 2 plus 1 minus 1, it will be 2, 2 only, right? And that is the only output, because if we take the last three digits like 2, 1 and minus 4, it will be 3 minus 4, which will be which will equal to minus 1, which is not the closest to 1. Okay, because 0 is there, so 2 is more closest, so we have to return 2. Okay, so we can solve it in different time complexities, but I will show you how to solve it using two pointer and O of n square quadratic time complexity. You can solve it in O to n to the power 3, like cube complexity, but that is not recommended. You should always try to optimize it. So let's see the optimized version. First of all, we are going to sort the element. What will be our approach? The approach is will be very simple. That first of all we are going to sort the elements, so that we can. The approach is more or less similar to the three sum. First of all, we are going to sort the array, and then we will have a stable pointer of I, and two pointer left and right, and we will in we will see every sum, and if we find the target we will return it, or if we don't find it we will calculate the closest, and we'll store it in somewhere, and we'll return that as well. Okay, so let's start sort the array. For sorting we will use inbuilt function. Let's have the int first. So size of the array, nums dot size, right? And sort the array using nums dot begin. We can sort it, and nums dot end, right? This is the inbuilt function we have. We all know for sorting in the C++. Now we will have a int closest. Okay, int closest close. Okay, int close, let's suppose it will be, I think I can have a int max. Okay, int max we can do, but we'll have to perform a absolute function, so I don't think that will be good for us. Oh, okay, let's see what happens. Okay, now Now it's simple. Now we'll have a for loop where we stable the in I pointer. Okay, I will be at 0 and I less than what will happen here, n minus 2, because we have to make sure the two elements must be there after ith index, because we are doing three sum. Okay, so there should be at least two elements after the I pointer exists. So I plus plus, and now we had now we will solve that int j is equal to I plus 1. Okay, after the ith index j will start, and int k will be n minus 1. Okay, okay, you can say that it is left and right, left and this is right. That will be more uh, that will look good uh, effectively. And now we will have a while loop, so that we can have the all sum of left and right. Okay, so uh, uh, while left is less than right, then we can say that in total I am making it local variable so that it can get changed in every iteration. Total is equal to nums of I, nums of I, because I will take the digit which is in the nums ith index, and nums uh, nums of left plus nums of right. Okay, and now we'll see if the total is equal to target, then we don't need to store anything and all. So we'll try that as well. If um, total is equal to target, then we can simply say that return the target. Okay, return the target or return total, anything you can say. Return total, let's say total will be returned. Okay, now if not, then what should we do? Then we have to calculate the absolute difference between the elements. Okay, so if not, then we should calculate the absolute value difference between the target minus total. Okay, the total something like here will be like 2 minus 2, and the target will be 1, so absolute will be 1 in this case. And it's if it less than the absolute of closest sum, which was we were taking int max, and minus target, then if it happen, if this condition satisfies, then we can say that close will be, we can update, we have to update the close as our total. Okay, we will update the total close. The close digit will be total, because the close and the target is very big, or bigger than the target minus total. So we will obviously do it. Obviously update the close integer. Okay, now now we have to iterate over the left and right. So if uh, total if total less than target, so what we can say that target total is so the left pointer is lagging behind something, so we'll plus plus will increase the left pointer, because if we increase the left pointer, then our total will be increased, because will get increased, because it is sorted. So if it is like in one, so after left plus plus it will be in two, so our total will get increases, right? So that's why we will do it firstly. If it is greater, then like it is in 2, so if the target total is greater than target, so then we have to decrease the right pointer, right? So else we will do right minus minus. Okay, that's the simple way you can do it. And now we will return the in this case we will return close. Okay. Now there is two problem in this code. Like if you see the example two, there is 0 0 0. So checking will be uh, not beneficial, right? Because we will check it, but it will not get changed anytime. So we have to consider this condition because it will run if you don't consider, but it will be waste of time and it will make our the code more time complexity of the code more. It will take more time to get completed, right? So we have to solve this constraint. Okay, solve this example. We have to code like that. So we can have here like if I greater than 0 and okay, and not work like that, and then like nums of I equal to nums of I minus 1, then what we can say? Then we can say quantity. Okay, quantity. Yeah, then we will continue. Okay, we will not do anything. Okay, this is the first problem we can encounter. Okay, now second problem is you can see that there will be close minus target. Okay, so if close we are taking int max, if target is like something negative, then let's target is negative. Then because target can be negative. Okay, see here. So if it is negative, then close minus of minus target, then it will overflow the int. Okay, so we should take it in more efficient and intelligent way that will be nums 0 plus nums of 1 plus nums of 2, because see, this is the highest that can be happen. Okay, that can happen because if nums 0, nums 1, nums 2 are not present, then uh, because this is nums length is 3, so minimum the closest target will be this, because we have made the sorting. Okay, so now this is the fine code we can work, and if the closest reduces, then we can say that okay, it is fine, right? So let's see if it runs or not. Yeah, it's working. Okay, let me show you if you are thinking that for this condition, for this array I am writing it. Let's make it int max first. Okay, uh, okay, int max, and I have the edge case, so don't worry. If we make it in max, then what will happen? Let's see. Yeah, let's see that uh, this test case will get failed because target is minus 100. Then when we are uh, see, this line is giving us problem. Okay, why? Because close minus target. So close is int max and minus of minus 100. So it get it will exceed the limitation, and you can see that integer overflow. There is a sign integer overflow. Okay, so yeah, this minus 100 is signed integer overflow. So you cannot do it. Okay, so you have to think it like we are doing it because okay, let's yeah, this is the code we should have. Okay, yeah, and let's submit it. Yeah, as you can see that the code got submitted, and this is the solution for this code. So the approach was simple, very similar to the three sum problem, and the time complexity, if you want to know, the time complexity will be O big O of n square, right? Time complexity of will be big O of n square, obviously, and space complexity will be big O of 1. Okay, so this is the optimized version of the LeetCode 16 problem, and that is three sum closed. Thank you.